So we want to welcome everyone to the afternoon session of the Kentucky Center for Mathematics. You can always find us at kentuckymathematics.org. In addition to that, you can find us on Facebook. So the one thing that I know is that Amy hosts watch parties when she's in the afternoon. She likes to host a watch party. So Lisa, I look forward to learning from you.
All right, thank you. And I look forward to our session today. We're going to try some new things, so that should be exciting. As we try this together. Our focus is on geometry in the intermediate grades, specifically grades 3 and 4. And welcome to our session. Just a reminder that you can find our upcoming events as well as the recordings at our virtual site on our homepage. And for today's agenda, we're going to just take a look at the research briefly that Bonnie talked about yesterday. It is the same research that we're looking at from Vanderwall and looking at some 3rd and 4th grade standards. Our topic is geometry. However, we're going to dip into measurement and data standards as well as geometry standards. We're going to take a look at a model lesson and some KMPI activities, some Desmos and GeoGebra. So sounds exciting. And just to remember what we looked at, if you were with us yesterday, Bonnie talked about these levels, the Van Hiele model of levels of geometric thinking that are referenced in Vanderwall, and they are in both the K2 Vanderwall book as well as the 3.5 Vanderwall book. So if you have either of those, you can reference these levels. But as Bonnie mentioned yesterday, the first level 0 begins with visualization, and then students work to analyze geometric shapes. And level 2 is that informal deduction. And as I was reading about the grade 3-5 band, it noted in there that most students are in that 3-5 band are still working in this 0 to 1 level of thinking, moving toward a 2. So that informal deduction is when students start making observations that go beyond the properties themselves and start to focus on logical arguments about their properties. So realizing what makes a square a rectangle, and that all squares are rectangles, but not all rectangles are squares. Making those types of arguments is that informal deductive reasoning that they can have. So in this level 3 and level 4 happen at high school and beyond for most kids. Okay. So just to remember that the levels are not sequential and they're not necessarily age dependent. Okay. So we need to provide the geometric experience. That is what's key. And our instruction, as we said yesterday, must match our students' levels of thought. Okay, so we're going to take a look at those 3rd grade standards and begin with that measurement and data. So in measurement and data, we are recognizing area as an attribute of plane figures and understand the concept of area measurement. So yesterday, that was a big focus of our topic in grades K2 is attributes, attributes, attributes. We want kids to be attending to the attributes, and that continues. And as we look at area as an attribute, okay, and being able to do things like tile and figure out what is the square area. So it's 3MD5, 3MD6, and 3MD7 are all related to area, and how that also relates to multiplication and addition as we look down at 3MD7. Okay. And we also want to be able to apply that knowledge of area to real world problems, area and perimeters. So, and putting things in context are always important. As we've talked about, if you've been with us in very many of our sessions, we're always referring back to context is important. So we're going to take a look at a lesson called Table for 22. And if I ran the whole video, it lasts about 13 minutes. It's an awesome lesson. I love, love, love this lesson. I'll give you just a little bit of a background. This teacher is a 6th grade teacher, but she is going to be addressing 3rd grade standards with her students because she wants them to make a deeper connection than just applying the formulas. So I love how she goes about introducing her lesson, but I am going to attempt to run it at a little bit faster speed so we can watch a little bit more of it. Hopefully it won't be too fast. We'll see.
Hi everyone, come on in. Yay. My name is Sunny Park.
Sorry. Hope that wasn't too fast, by the way.
Hi everyone, come on in. Yay. Come on in. My name is Sunny Park, and our lesson is on area and perimeter, a table for 22. Math spiral, open to a clean page. Students enter the room and you start with a whole group lesson just so that you can get them all on the same page and they're all listening. And you start with a challenge. We're going to pretend that we all want to sit together for a Thanksgiving dinner. And I want the table to be rectangular. The challenge is this. I want you to figure out, what does the table look like if it must be rectangular and if everybody must sit at the table? And what's the biggest table I can have so that I can put the most food in the middle? After you figure that out, I have another challenge for you. With everybody sitting at the table again, what's the shape of the table that's going to have the smallest amount of space? So, what's the biggest table going to look like where everybody sits? And what's the smallest table going to look like where everybody sits? The kids knew perimeter and area as isolated topics for geometry and of doing something with shapes. And so what this lesson really did was to take it to another level of critical thinking where you can see both of them happening at the same time simultaneously. And your place at the table is going to be this piece of this yard of poster paper. Now this is 3 feet long, okay? This is your seat at the table. There's 22 of us, and everybody must sit there. No overlap, nobody sitting on each other's lap. Side by side, and this is your chair. And so when you put your place down, you put it down like that, and that's your place, and you just stand behind it. Okay? The practice standard versus the content standard, they're equally important. You create your practice by knowing the content first. Clarissa, what do we know about rectangles?
They have 4 sides.
Yes, a rectangle has 4 sides. So we want to make sure that our table has 4 sides. What else do we know about rectangles that's going to help us brainstorm it?
All sides are straight. There's none that are curved.
Okay, so we have straight. The lines are straight. Vanessa?
The lines that are parallel from each other are the same length.
Okay, so the opposite sides are parallel and they're the same, what everyone? Length. Same length. But right now, we're not going to design anything. We're only going to talk about it. So in a second, nobody's going to get this yet. You're just going to get into your groups. You're going to sit down, and you're going to have a discussion for about 5 minutes, okay? And then after that, we're actually going to see if it works. We could have gone straight from the whole group where I introduced the activity to the activity itself, but it would have been mayhem. It would have been chaos, right? Everyone would want to speak over each other. And when you have it divide them into groups, you're giving all a chance to say something because they all want to say something. And you guys are so good at working in groups. I know that you're going to come up with really good ideas, and then we'll share them out, and then we'll actually try it. Do you think you can do the challenge?
Yes.
Okay. So on the count of 3. 1, 2, 3.
Each side it will be 11, so we will have 22. We will have 22 people, but then we have space for 4 more at the ends of the tables.
How many tables or how many seats? I think seats. Yeah, because like tables, draw a rectangle, kind of squarish, and then we take one from these sides and put another on this side, and from this side we take another here.
Yeah. So then we just extend it a little bit. That way another person can come on the side.
You can try to make it as much as a square as possible.
Yes. Today I was very pleased when I visited each group, and every group was engaged in math conversation about area and perimeter without knowing it.
You know those Renaissance tables, are like those big ones that they have like a whole bunch, and then they have like the queen and the king, like
The king and the queen, and they barely talk, right? Yeah, it was just wonderful when Alex, he made the connection. I've seen something like this. It's when in the Renaissance time when the king and queen would sit at their dinner table. There was all this room between them, and you know, they didn't talk very much, and that connection was great. Is that the biggest table that I can fit the most food on? Or is it the smallest table that I can put the least food on because I don't have enough.
I think it's that one.
During the lesson, I was thrilled when the students made the connection between the activity and area and perimeter. What is the most space possible in terms of a table?
So now we're looking about area. So 1 times 10 is 10.
And it just kind of came up in one of their groups. So what's the area of this table?
That's 20 by 22 by.
No?
What is the area be 10?
10 square yards.
Yeah.
What's the area here?
But then you have 6 times 5.
What is 6 times 5?
30.
That's a bigger area, but is that 22 people?
Yeah, it is.
Okay, everyone, back to your seats with your ideas. Everyone, come on back. This started out as a challenge problem, but then as you were talking in your groups, a lot of you actually had a light bulb go off, ding, where you said, oh my gosh, this is math. I'm using math to figure out this real world problem. If there's no application, the students will think of area as multiplying the length times the width, and that's it. But what is it really?
There's like one person right here, and there's like one person right here, and there's like people right here.
It's the space inside, and not everyone knows that it's the space inside. Okay, space inside, but what do you mean?
At first we studied the rectangle and the possible ways we could do, and then so we wrote down all the possible ways, and then we found the area of them, and we found what was the largest and what was the smallest, and then so we made our rectangle based on it.
Well, when you talk about a table, then the space inside becomes how much space is there for food plates.
So basically what we're doing here is finding the area, which is how much food could fit in. So 10 by 1, the area would be 10. Then if the table was 9 by 2,
Some groups had decided to go straight away into the diagram and to draw a picture. Another student chose to do the table, the data table, where they had the different values on either side.
the area would be 18, this area would be 24, this area would be 28, and this area would be 30. So then we see that this is the largest and this is the smallest.
A mathematical connection. What we're going to do now is we're going to actually put your design to the test. Usually the objective is the content standard. Now, how do you teach it is the practice standard. And that's where the teacher has a choice to teach it a traditional way or to teach it in a way that you feel will provide relevance and experiential knowledge for the kids. I want your crates and I want your desk pushed out toward the perimeter so that there's a big empty space in the middle. Once you get your strip, can you sit down on the floor? When I turn around, you're going to have probably a minute to get yourselves in order. Try to do your best with right angles and no overlap. And first, we're going to do big table. On your marks, get set. Go.
Okay, because we have 5 people right here. Alright, up here. 5 over 6. It's gonna be way longer than this. It shows the end of 5.
I had the option of using rope and having them just kind of do something with string, but I think that them becoming part of the perimeter had a lot of value.
Put the bed up! Stand up! She's right there. I'm on the bed. 1, 2, 3, 4, 5, 6. We're doing this side.
I'm about to turn around. And so if I was just watching them the whole time, they wouldn't find any satisfaction of the finished product. So I do that a lot. I say, I want to turn around and close my eyes. And when I turn back around, I should see it. And they're like, oh yeah. My eyes are still closed. And now they will open. Wow. 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 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What is the perimeter of this rectangle?
22 yards.
22 yards. And what is the area inside?
30
square yards. Interesting. Task number 2. I'm going to turn around again. And
All right. So I'm going to stop our video there because of time. And just if you want to unmute and have any reflection on what you saw.
They will always remember how to find area and perimeter from that activity.
Now, isn't that awesome? I just love that lesson. Love it.
Yeah, I love the activity too. I think, yeah, that's the kind of thing that's going to make it really stick. Like it made me stick just watching them, you know, like it's a fabulous example of a really activity that's kids are going to be not only engaged in, but they're not just engaged, but they understand the concept when they're finished. A lot of times we have engagement, but then they forget what they've even, like what the purpose of that activity was. But this one combines both. So it's very good.
Yeah, yes. And the student engagement, the student ownership, and the way she presented it as a challenge, I thought was awesome. And not giving them the takeaway at the beginning was a good teacher move. And anything else that you guys want to talk about? And I have linked this. You can click on, it'll be in, this video is in the presentation. So if you want to go back and watch the whole thing and see, they do go ahead and make the smallest table, but for time purposes, we will continue on because I do have some other awesome stuff I want to share with you guys. But that is an awesome lesson that helps kids make those real world connections between area and perimeter. Because so many times in my experience as a classroom teacher, kids would forget the terms. They would forget, what do I do to find perimeter? What do I do to find area? And it was simply because they didn't have enough experience in relating that term to what it meant. So that's one way to develop that and make that connection. I think they won't forget that. So hang on, it's not letting, oh, there we go. I wanted to share with you guys some activities from the Kentucky Numeracy Project that can help kids to make those connections to area. This is a 3rd grade activity of tiling and counting. KNP activity 4448 has scaffolds some of these tiling activities for 3rd grade standards. So it begins with tiling and counting, where we provide those 1-inch tiles and their tiling arrays. So that's where it starts. And these are all in your handouts. Then task 2 is scaffolds that where we see a row, but the rest of the tile is open. And so kids have to figure that out. And the next scaffolded piece is where we just have the tick marks, but then the area is open. Right? And they're doing that tiling and finding the number of square tiles needed to cover when they only see the edge marks. And then the next scaffolded piece is tiling with numbers, where there's an open rectangle and figuring it out and making that connection to, in the beginning, it's repeated addition. As we progress, it progresses to multiplication. So it's a very nice progression with that tiling piece. So all of that is provided for you guys in the handouts. Any questions about that? Okay, nice, thank you. So we're gonna move on. So in 3rd grade, we have those measurement standards that have the cluster that is geometric measurement, but we also have geometry as a standard as well. And then in that geometry standard, we're classifying polygons by their attributes. Okay, so looking at quadrilaterals and rhombus and understanding those shapes in the different categories and what shared attributes they have. And putting them into categories, and also partitioning shapes as well as, and we talked about that during our fraction work not long ago. Okay. And in 4th grade, in the geometry strand in 4th grade, we're looking at points and line segments, rays and angles, but we're also classifying 2-dimensional figures. So and symmetry. So you guys can see that these geometry standards are like a lot. And we only have 30 minutes. So I had to kind of pick and choose what I wanted to focus on. So the activity that we're going to take a look at is going to help us to hit on the 4th, this could be for 3rd grade or 4th grade, depending on the what they pull out of the activity. So I'm going to stop my share for just a minute so that I can, we're going to take a look at a Desmos activity if you guys want to be students. And I'm going to put in the chat, unless you're working from a phone, it should work if you're on a tablet or if you're on a computer. Let me see. If you will just go to, now I put that in the chat. If you'll go to Desmos from that link, it should link you up with somebody else in the group, and we'll take a few minutes to just play the activity with the person. So it's kind of like Guess Who, except you're guessing a shape. So one person will be the question asker, and the other person will be trying to guess the shape that they've identified based on the clues. So, and you guys can just kind of play it together, and I will be the teacher. So,
let me know what you need me to do, Lisa.
okay, I will, because I will be looking at my Desmos desktop. But I don't want to share it because I don't want everybody to see like what all's going on at that moment. So
yeah. So I'm going to put the student code in on my iPad and wait for your instructions before I hit enter.
it looks like we've got 12 people in. So that should be even for partners unless, I'll just see if everybody gets partnered up. Okay, looks like we have 1, 2, 3, 4 people waiting for a partner, so they should be getting paired up together. Sometimes it takes a little bit of time. Okay, now I only have 2 people that need partners, and that should put you together, we'll see. so if you guys want, have had a few minutes to play the game, some of you had a chance to finish and some of you are still working, but you've had a chance to kind of experience it. If you want to log out and we can kind of pull things back together. And tell you what I'll do. I will share my screen again, and this time I will share my Desmos. What I was able to see as the teacher. Okay. So you guys should be able to see now what I was able to see as the teacher. So I could see how many students I had, and for some reason it said, Bonnie, I know you were in there. Because you got finished. So I guess that's why it said you were waiting for a partner. Hopefully everybody got partnered up and were able to play the game. But so it shows the games and if you got finished and if you guessed correctly or if you didn't, and the questions that you had were there, the time and the different questions. So if you got finished, you may have been able to see. So now let's go back to the PowerPoint and I can kind of go through. I did take some screenshots of what it looked like just in case that didn't work, but I'm glad it did because hopefully you guys enjoyed playing that little game and experience. Anybody want to comment or share anything of that experience?
Yeah, I was kind of slow because I was multitasking and didn't get started right away, but I really like the aspect of being able to pick your answer and then eliminate the figures that answer eliminated. And that was really cool. So I think it was a great activity. It'd be a great activity to play with the class first against you as the teacher first.
Yeah, that might be a good way to introduce it depending on your level of your students. Okay. But so you select the quadrilateral that's special to you for any reason, and then you're going to, if you're the guesser, and this is just a screenshot of how my game went. But you can see I picked a square. So, and then her question was, does it have right angles? Is it a rectangle? And then at the end of the game, I don't know if any of you guys got to, oops, where did that go? Got to that point. But at the end of the game, then it gives you some kind of summative questions too. So when you do 2 rounds, each person gets to be the guesser, the picker or the guesser. And then at the end of the round, there is this question. So it's kind of a more of an open-ended question where you have to apply. And then you switch roles and get to choose and guess again. And then here is the other question before you start your next game. So in this one, let's think about this as a group. Here are our 2 figures. Select all of the questions that would help you figure out the difference between these 2 quadrilaterals. So you can kind of read over those. Which questions do you think would help you figure out the difference between those 2 quadrilaterals? Jennifer's, I see that in the chat, Jennifer. Yes, Desmos is free. You just sign up, and I found this in the elementary section. I think there are about 9 activities that are already done and placed in the elementary section, which is really nice.
Kaylee's, are we supposed to talk?
Sure, I would love it if somebody could talk.
I thought Kaylee's was a really good question. Are all 4 sides the same length? That eliminated one right away.
Yes, so that one. Okay. So Ryan's question, does it have an angle that's about 60 degrees, is probably not going to help us because both of those angles appear like they might be close to that. So that one might not work. Somebody says Lewis's question would also work. Does it have 2 long sides and 2 short sides? Yeah. So that one kind of tells us it's that one too, right? Okay. Why does Isaiah's not help us?
Because neither object has right angles.
Yeah.
Yeah, I'm assuming that seems like a question that would already been asked that eliminated, that got down to these 2 figures. So
Right.
that's not going to help us.
Yeah, so at this point, neither of those have right angles. So, but that doesn't mean students might not ask questions like that, right? So
It's a good thing to look at, to think, oh, as a formative assessment question, I need to know that student has some things I might need to dig deeper with about right angles.
yeah, so as students work through this kind of activity, you will see their vocabulary get better and better, because they'll be looking more critically at and being able to be more precise in their language, right, with these types of activities. So it's good practice. So that is linked in our session. So hopefully you enjoyed that one. I did. Okay. Taking a look at those 4th grade standards, we want to think about, because I know my time is flying away. Yep, it sure is. Okay. Angles and measurement of angles is a challenge in 4th grade. So if you taught 4th graders, you know that. Another thing I'd like to share with you guys is from GeoGebra about lines and angles. Okay, and I have a link here that I'm just going to click on, and it goes to GeoGebra, and I'll just different angle types. Being able to recognize those. This is just a little demonstrator that can demonstrate acute angles, and you can stop it at any point and talk about the measurements and what makes it acute and define it. So the same thing for right angles and obtuse angles. Right. And one other really cool thing that I thought was nice here is the protractor practice, because learning to use a protractor can be a challenge. So, for example, and you can move these lines. So it says to move points A, B, and C to create an angle and then measure it. And so make that whatever I want. And you're going to use these points to move. So I'm going to move my protractors and line that up with B. Actually, I don't need to do that. I'm gonna move it around this way. So if I put there, and then to move my protractor, I can line that up. My 0 with the line, so that I'm measuring from 0 over here. And if you want to extend your line, you can extend it, so you can see where it is. Cool. And so that is cool. And you can change it to different types of protractors too. And there is a place to check, but I am there. I couldn't see it because it was blocked, but yeah, so it shows you the actual measurement and tells you if you were close enough. So you can see, because it does give it in not whole numbers, but you could tell your kids to if they're within a degree or two that it's close enough. And there's random practice too. So this one just gives them the actual angle that they measure. So it is kind of a neat thing. And GeoGebra has some other, if you're one, these are applets that were already made by this author. But if you wanted to get in and play with it, you can also do some things in there as well and your students might be able to do that with drawing lines and angles and rays with GeoGebra. And I know one of our other RCs, Leah White, is good at GeoGebra. She knows a lot more about it than I do. She's had a lot more practice, but it is a nice virtual tool. So let me get back to, there we go, our PowerPoint for the day. So just to wrap things up, we've shared our lesson that you guys can go back and finish watching, and we have shared the Desmos activity, the KMPI, and the GeoGebra. There will be more geometry tomorrow, I think. So join us again as we move on to 5th grade standards, and I think Kelly will be hosting that tomorrow. So I'm sure she'll have lots of good things to share with us. And just remember, KCM's here to support you, and reach out to us anytime, and we'll be glad to do what we can to help you.
So that was super fun being in Desmos, partnering us up and taking a look at that activity. So geometry is one of those things that's dynamic. It's always important to do hands-on activities with students. And at this point, we really appreciate Lisa and her leadership on this. We'd love for you to unmute and give her some of your favorites, some of the things that you really did enjoy with regards to today's presentation.
Yeah, I'd like to talk. This is Jennifer from Austin, Texas. I've been at most or a lot of these presentations. This is probably one of my favorites, actually, Lisa, so thank you. And it's because I felt like I have not just thinking parts and like, okay, now I can go kind of do it. And a lot of the other ones had good parts too, but I mean, they all been good. But this one, I felt like I took away a lot of, I could immediately go and apply. I just felt like it was just super, 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 super meaty. So thank you so much for that. Just so teacher, I mean, I could tell that you're a teacher at heart. So that's what I feel like. Thank you.
Thank you. I appreciate that.
Lisa, it looks like people loved those activities. Jennifer speaks for all of us in that. It's always wonderful when you get in there and you really find things that we could use in, if I had to teach a class in an hour, I would have some things to teach students that I would be so excited to implement. So indeed, KCM is here every afternoon for you guys, and we are thankful for you all spending your afternoon with us. So see you tomorrow. We'll continue with our geometry standards.
Bye, everybody. Have a good afternoon.